So, good morning, students. Today we will discuss about the another instrumentation part, that is atomic absorption spectroscopy. Now, in this atomic absorption spectroscopy, which deals with the absorption intensity. So, as the heading itself will indicate, it is an absorption spectroscopy, not the emission intensity, as like the flame photometry is not calculated. The reverse of it, that is the absorption intensity, is calculated. So that is the name which is given, atomic absorption spectroscopy. So in this atomic absorption spectroscopy, what is the principle of atomic absorption spectroscopy? Now the principle is that, so in the previous session, so we have discussed about the emission intensity record measurement in the flame photometry. So when a solution having a mixture of metallic species is introduced into the flame and aspirated, the solvent evaporates with the help of the flame and vapors of the metallic species is obtained. When these vapors of metallic species is obtained, some of the metal atoms can be easily raised to various sufficiently high energy excited state and emit certain characteristics radiation of the metal when it comes back into the ground state. And this phenomenon is used in flame photometry. So flame photometry uses this phenomena, and during the excitation process, not all the metal atoms will get excited. Some of the metal atoms will remain in the ground state. That remaining metal atom which is in the ground state are called as non-emitting ground state which will not emit any radiations. But these remaining metal atoms which are incapable of exciting into the excited state will absorb certain light radiations of their own specific resonance wavelength. Now that absorbed radiation is recorded in the atomic absorption spectroscopy. Now in this way, when a light of this wavelength or light of particular wavelength passes through the flame, a part of the light will be absorbed, and the part of the light which is get absorbed, the absorption intensity. This absorption intensity is proportional to the intensity of the atoms in the flame. So in an atomic absorption spectroscopy, the amount of light is absorbed is determined. And this amount of light absorbed will give you the amount of the metallic elements present in the ground state. And from the ground state, how much is the concentration of the metallic element present? We can easily calculate how much is the concentration of the element or a metal getting excited. And this absorption intensity is proportional to the concentration of the element. So an absorption intensity is calculated for atoms or elements present in the ground state which are not capable to absorb into an excited state. Now in the flame photometer consists of again a pressure regulator and a flow meter for fuel gases, LPG gases, an atomizer, a solution preparation chamber wherein this atomizer will be used to introduce the sodium chloride or potassium chloride solution into the flame burner, and an optical system, lens, filter to collect the absorbed intensity, and a photosensitive detector and an output recorder. Suitable filter is used depending upon the element to be detected. For sodium 589 filter is used. Is inserted between the flame and the detector. Again, LPG is used as a fuel and air is used as an oxidant, and combination of these will give you almost a temperature of 1900 degrees Celsius. The whole analysis depends on the flow rate of the fuel, oxidant, and the rate of introduction of the sample in the droplet size. Now the procedure is same. The sample containing an analyte is aspirated. Sample is introduced into the flame by a suction atomizer, and in the form of a small spherical droplets. It's like an aerosol mist, and the radiation from the resulting flame is collected. This radiation is the radiation which is the absorbed radiations. So certain intensity of radiations will get emitted by the atoms which is getting excited from ground state to the excited state, and certain radiations are getting absorbed by the metal atoms or elements which are not excited into the excited state, which remain in the ground state. So the metal atoms which is remaining in the ground state is getting absorbed with a certain light intensity. So that intensity is nothing but absorbed intensity, and that absorbed intensity corresponds to the number of atoms or elements present in the ground state. From that we can calculate what is the concentration of the particular element or metal. Now, instrumentation of atomic absorption spectroscopy. Now, this is the schematic representation of atomic absorption spectroscopy, where you can see very clearly the source. The source is your atomizer with the gas units, oxidant, and the fuel units, and the nozzle, where sample is introduced in the form of a small droplets and vaporized, and when it gets vaporized, the atoms get excited into the excitation state with the different excitation state, and some of the atoms will remain in the ground state. And this atomic absorption spectroscopy, some of the atoms which are remained in the ground state will also capable of absorbing certain frequency of its own wavelength, and that absorbed radiations will be gathered, passed through the lens, and it is being synchronized with the monochromator. Okay, so monochromator, it will synchronize the absorbed radiation, and it will pass through the prism to converge this radiation into the detector, and detector will detect the absorbed radiations by the non-excited metals. Now you can very clearly see radiant source is a hydrogen lamp is usually used as a radiant source. An atomizer generally burns burners which are used to break up the liquid, that is converting vapors of liquid into a gaseous form. Now the hollow cathode lamps, so these lamps are constructed for individual elements, but multi elements lamps have been prepared for all the purposes. So this multi-element will detect different metal atoms, and monochromators are the gratings and the prisms put together, and the lenses and slits are used for the determination of potassium, sodium, calcium, magnesium. It is suitable for especially for sodium, potassium, and even you can detect calcium and magnesium with the help of atomic absorption spectroscopy. Detectors, the photomultipliers are used as detectors. In some of the instruments, two filters and two detectors are also used to compensate the fluctuations in the source. So two different detectors and two different recorders will be used in some instruments, so that the absorbed intensity will fluctuate, and that fluctuations can be easily correlated and calibrated. Now the procedure for, first of all, the meter is adjusted to zero absorbance uh, or 100% transmittance, zero absorbance or 100% transmittance. When a blank solution is aspirated into the flame, and a light of hollow cathode lamp passes on the photomultiplier tube. Now the solution to be investigated is introduced as a certain part of the light is being absorbed, resulting in decrease of light intensity falling on the multipliers. So the absorption intensity which will goes on decreasing. This gives a deflection in the meter needle, which is noted immediately. As this is a comparative method, hence a standard solution of elements are used to make the calibration curve. So as in the similar case, a standard solution of 2, 4, 6, 8 and 10 cc of the sodium chloride solution is being made and aspirated into the flame, and absorption intensity of these solutions are measured with respect to the concentration of the element which is being calculated. Now the graph looks like this. Now when you look into the graph, especially the absorption against let us say the copper concentration in ppm, so absorption intensity now go on initially go on increasing, then it will go on becoming a flattening, so it is not completely a straight line. So you get absorption intensity like this for the calibration curve of sodium chloride. If you want to detect 2 to 10 cc of the solution to get 5 different readings. So absorption intensity graph will be like this. So absorption of radiation and with respect to the concentration of the element. Now the test solution is being done with the similar procedure. For absorbing absorption of the test solution is also measured. Absorption intensity of the test solution is being measured, and from the absorption intensity of the test solution, what is the concentration of sodium is being calculated. Now the constant result is concentration of the test solution in ppm. So